Hello, today we will be talking about optimal foraging in fish. So we've spent a lot of time looking at behavior of predators, behavior of prey, and how fish work in those two roles. But there's more to a fish's life than just that. You don't spend all of your time avoiding predators, avoiding being a prey, looking for prey. You have to kind of balance those two things out. So we need to talk a little bit about how fish forage and how they make their decisions to decide where they need to be. So a fish basically is trying to eat the most food it can using the least energy, right? It wants to get the most energy it can possibly get with the least amount spent. So they have to balance the costs with the benefits. What's the cost of getting that food and what are the benefits of getting that food? There's this whole theory in ecology looking at optimal foraging. And this is the idea that animals are going to maximize the benefits to cost. So this is something that they use in behavioral ecology to kind of predict how an animal works. That it has to have the ability to assess the relative profitability of different efforts or patches. So if I spend all of my time going to this patch of seagrass, at what point do I decide that this patch doesn't have enough food in it? I should go over here. How do they decide what they're doing? And the idea is that to maximize fitness, that an animal is going to do whatever it can. It's the way it forages is going to maximize the benefits for the lowest cost. So you maximize the net energy that you gain, right? So you want the greatest return for your effort. You want to maximize that energy intake and minimize the energy output. And this is where we get into that risk balance, foraging versus predation risk. How do you balance those two things? Potential prey needs to eat too. So you can't just follow that optimal foraging theory and say, I'm going to go where it costs the least amount of energy, because you have to worry about predators as well. And we see that fish will decrease their foraging rate in the presence of predators. And smaller individuals will react to predators differently than larger individuals. And if you're hungry, you're starving, you are willing to accept more risk when it comes to foraging. Fish appear to have the ability to determine that threat sensitivity and adjust their behavior accordingly. So we've got a series of experiments to look at here that kind of look at some of these questions. So we'll start with bluegill. So this is one of our centrarchid sunfishes. They're pretty common. And they did an experiment to see if bluegill eat whatever they find or if they're selective. Do bluegill change their prey choices based on availability? Are they selective foragers? You would think if you're selective, then you're doing it optimal, right? That you're not just picking whatever you come across. They feed on zooplankton. So this one here is a daphne. That's obviously not to scale, right? They're not as big as the fish. They're those little tiny things swimming around. You can almost see daphnia in a dish, a petri dish without a microscope. You can kind of see them a little bit if you know where to look. So let's see what we can tell about bluegill. So we have our bluegill, we have our daphnids. And what we're going to do is we're going to put a certain number of daphnids out there. So we'll have a number for each size class. We'll have some that are small, some that are medium, and some that are large. And we'll have it be relatively, either have lots of daphnids, a medium amount, or very few. And then we're going to score the fish based on how it eats those. So the relative feeding rates of the bluegill, if we get a dash, it's negligible. It didn't really eat any at all. 1 asterisk some, 2 asterisks second most frequent, and 3 is the most frequent. So we'll start at the first level. 350 daphnids per size class, overabundance, so many daphnia, they're everywhere. And what does the bluegill do? Well, it pretty much ignores the small ones and the medium ones, and it eats the large ones as much as it can because there's so much food. All right, we'll go for an intermediate level. Now we'll have about 200 for each of the size classes. And we see that we eat some small, a middle amount of the mediums, and mostly we're eating the large ones. All right, what if we starve the poor little guy? We'll give him 20 of each. So those are considered to be starving densities. And we see that we eat some of each group. So this shows that the fish is able to change its foraging rate based on the ability of food. When it's starving, everybody's equal. If I see a daphnid, I'm eating it. But if it's lots of things, it can be picky and just selectively pick the large ones because that gets the most energy for that fish for its hunting output. But if there's not a lot of food, it realizes and switches its behavior so that it's able to eat whenever it sees food. Well, what about sculpins? We'll look at a different fish. What determines their prey choice? Did they forage selectively? So sculpins usually eat crustaceans, think like insects, insect larvae. Mollusks, those would be more like snails. And what do they prefer? Well, under natural conditions, they're eating crustaceans first. They're much better than mollusks. That's their preference. But if we go in there and we manipulate the food source, so we go into their little stream and we take all of the crustaceans out, will they starve? Well, no. At that point, then they do switch over and start eating those mollusks. The thought is that the sculpins, by choosing crustaceans over mollusks, they're selecting the food items that are most digestible, the ones that are easier for them to get the energy out of. However, they do note that their food choice is dependent on food availability at different times of the day, so they will adjust it depending on which type is easiest to find. So there's a trade-off there by both, right? It's going to be whatever's easiest for me to find as well as what's most digestible. And at some point, you reach the point where it's better to go one way or the other, depending on your availability of food. When we do an observation in the stream, we'll look at salmon and trout. Do they forage differently if you have a fast-moving stream or a slow-moving stream? So they have the options, right, within their water, right? You can go in the slower-moving parts, or we can move up where it's faster. Will they choose one set of conditions over the other? What would they prefer? What we see is that given the choice, so if they're in a habitat that has both fast-moving and slow-moving areas, they're going to go to the slower-moving water first to search there. They're going to evaluate the quality of food in relation to energy expenditure. So by searching in the slow-moving water, it doesn't take as much energy, right? They're not trying to fight against a current. And they'll see how much food is there. If there's enough food there, they don't have to go to the large. But they'll check out the slow, and then they may go check out the fast-moving and then figure out where they need to go. And they're going to ignore the losing propositions. Basically, they're lazy. They're going to use as least energy as they possibly can in order to get the most food that they can. They're not going to go necessarily spend a lot of time in the fast-moving water just because it's there. They'll only forage there if they're getting enough food for their effort. And we can see some predator avoidance. So we've looked at how they forage, and we got to throw predators into the mix. They want to get the highest quality food, but now it's got to be at the lowest risk. And when we do experiments, fish feed less in the presence of predators. So we have predators present, we remove the predators, how does their behavior change? So our bluegills there, if they're given the choice, the juveniles are going to feed in open waters, swimming around, finding those zooplankton, right? Finding all those daphnids. But if you put their predator, the largemouth bass, in there, then the smaller juveniles, they move into the vegetated areas. There's less food in the vegetated areas, but there's less mortality if you stay there. The predator, the bass, don't go after you. The larger juveniles, they stay out and continue to forage in the open water. They're too big for the bass to eat them, so they look at the predator threat and decide it's not really a threat to them. The smaller ones look at the predator and say, that's a big threat, that's worth not eating all those zooplankton, and they go back into the vegetated areas. Sticklebacks over here, if you have a predator present, they will feed slower. Even if that predator is behind a partition, so it's not actually able to swim where they are, but it's there and they can see it, they'll feed slower. Gobies as well, they change their feeding behavior if you have a predator there. They'll eat less in the presence of a predator. Both of these are probably spending more time observing that predator and less time focusing on their food. So looking more at predator avoidance, highest quality of food at the lowest risk. That's what we're trying to balance here, right? We want to get the food, but we don't want to have the risk. What level of risk is acceptable? Well, fishes will choose the less exposed habitats in the presence of predators. This is a habitat manipulation experiment where you're giving them two choices of habitat, which way are the fish going to go. They'll forage more often and more exposed without predators. And that makes sense, right? If predators aren't there and the food is equal or better in the open habitats, then they'll forage out in the open areas and be more exposed. But if predators are present, then they're going to move into the less exposed areas. More of a predation risk. Just a brief aside on experimental design. Want to point out that we have just talked about 3 different kinds of scientific evidence, right? We had lab experiments where we were manipulating the fish in the lab, changing their conditions in a lab setting. We had field observations. That's like the salmon, right? We went out and looked at the salmon and trout. What are they doing in slow moving streams versus fast moving streams? Not really something we can manipulate in the lab very easily. You can't mimic that. And we had a field experiment where we went out in the field and we manipulated what was there in a natural setting. So that could be the vegetation example, giving them 2 choices of habitat, right? Removing vegetation from areas, adding structure to see how they work. 3 different ones, right? So we get 3 different types of results from those to make different kinds of conclusions. Lab experiment, we can manipulate more factors on, but it's not as natural, so it's hard to know what we're actually testing. Field observation, all we can do is look at what's there. We haven't manipulated any factors, so there may be other things that are happening that we're not aware of. Field experiment is where we're actually manipulating part of the experiment, but in a natural condition. We're introducing something or removing something, changing the natural habitat, and then seeing how the fish react. So it's just 3 different kinds of experimental design. Back to what we're looking at, the highest quality food at the lowest risk. It's not as straightforward as the experiments that we've talked about necessarily state. The feeding behavior of those fish can change dramatically when they are starved. We got a hint of that with the bluegill, right? That we did that experiment with, where that'd be the lab experiment, right? We gave it different levels of food to see what happened. When it was starved, it changed its feeding behavior. The threat sensitivity changes as well. What looks like a big threat at some points cannot be as much of a threat. You might let that predator get a little closer to you if you're starved than if you are fairly well fed. Laziness can be okay, right? It can be fine. You don't have to go out and search for food all the time. If it's easiest way to get food is usually what the fish are going to choose. So it's fine to be lazy, unless you're studying for your test. Don't be lazy, study for your test. And we had looked at those different types of behavioral evidence as well, right? The idea that each of those experiments give us kind of a different view of what we can learn about the fish. So we talked about fish foraging, kind of trying to link together what we've talked about with prey behavior and predator behavior and show that it's not just an individual thing that the fish is looking at, right? That we're weighing lots of different things with those costs and benefits. We have to analyze those and balance them and see what works best. The threat sensitivity is going to vary with the condition of the fish, the prey availability, whether the fish is starved, and they have to weigh that energy cost and predation risk against the energy needs. And that's what fish are doing. So it's not as straightforward as I am a prey fish, I am a predator fish. There's other things at play there as well. So as always, as you're reviewing this, if you have any questions, please let me know. Thank you.